Accurate autonomous assessment of current local sky conditions can be used to estimate solar irradiance for regulating hybrid power supplies. In this work, we use convolutional neural networks to precisely segment whole sky images into basic cloud types. While our idea parallels earlier work on machine learning classification of satellite imagery, contemporary machine learning methods automatically generate features in lieu of handcrafted metrics. The objective of our project is to convert a whole sky image into an estimate of solar irradiance. First, though, we analyze a whole sky image by cloud types and percentages. These cloud types and percentages are fed into a solar irradiance model, first developed by Shapiro in the early 80s and later refined by researchers at the Army Research Laboratory. The data set we use for training our machine learning model is a small set of labeled cloud images that we obtained from the internet. We cut each image into smaller 32 by 32 pixel blocks. 6 relevant classes were defined: cumulus, cirrus, stratus, stratocumulus, cirrostratus, and sky. We also included one irrelevant class, where we basically used random photographs. In addition to our machine learning model, we also predict the sun location and mask that out from our predictions. The method that we use for machine learning is the typical supervised convolutional neural network, which involves multiple layers of convolutional kernels that are then downsampled until we reach a small space that is then softmaxed to yield a label prediction. The whole sky images were obtained from a Raspberry Pi camera. As you can see in the results, for an overcast sky, we get a fairly good prediction. As we move to partly cloudy skies, there are sometimes a few challenges where the cloud type is unable to be predicted and is considered other, or the color red. The worst case seems to be when we have a clear sky and we would expect 100% sky and 0% clouds. Instead, sometimes we get a pretty good measurement of sky, and sometimes we either see other or certain cloud types. Anytime where the picture ends up being bleached white, this can be misinterpreted by the machine learning model as clouds. In conclusion, we think that the model does a fairly good job, considering that we didn't actually train on whole sky images. We trained on random images we found on Google. However, the leading challenge seems to be when there's a fully clear sky and the sun is bleaching the cover of the Raspberry Pi camera. In the future, therefore, we're going to look at alternative covers that have less glare or bleaching. We would like to thank Mr. Morris Berman and Dr. Robert Jane for their helpful discussions. And thank you for checking out our poster.